Alright, this video we're going to talk about inverse functions, and we're going to focus on actually just finding the inverse function, and then we'll talk about more of the properties, like what's the relationship between the graphs, what happens between the domain and range. We'll focus on that in a later video. So today our goal is to be able to find inverse functions. So we have a set of steps here on how to find an inverse, and we start with if the notation is an f of x and we want to change it to y equals x notation, and then go back to the f of x notation. This notation right here, that -1 is not an exponent, it represents an inverse. So we'll go through the set of steps with this first example. Alright, so we have this function f of x equals 2x minus 3. And we should recognize that as a linear function. We're going to change that f of x to a y. So that's our first step. Then a relationship between inverses is that x and y, or domain and range, actually switch. So now we're going to rewrite this, but wherever there's a y we're going to write an x, and wherever there was an x we're going to write a y. We now have a new equation that we can solve for y. So I'm going to add 3, and we get x plus 3 equals 2y. Now to finish this and solve for y, I'm going to divide by 2. Notice I'm dividing that whole left side by 2. So we get x plus 3, that whole quantity, over 2 equals y. And I could also write that as y equals 1/2 x plus 3/2. Either way is acceptable. Now this is the inverse function, so I'm going to write it back in function notation. So the inverse will be 1/2 x plus 3/2. Alright, now I want you guys to pause the video and try B on your own. Okay, so check your answer for example 1, letter B, and you should have the following as your inverse. Alright, we're going to do D, and then C is going to be something you need to try for homework. So we're going to rewrite this as y equals -6 x plus 2. Next step, we rewrite, replacing y's with x's, x's with y's. And now we solve for y. So x minus 2 will equal -6/5 y. And now we need 1y, not -6/5 times y, so we multiply by the reciprocal, and that gives us 1y. Whatever we do to one side, we got to do the other. It's just one negative. So it's -5/6x. I'm going to distribute, plus, and that'll simplify into 5/3. So the inverse function would be -5/6x plus 5/3. Notice when we start with the linear function, its inverse is just a different linear function. So example 1, letter C, you should complete that one, and we'll check that tomorrow. Now we're going to move to some examples which are in higher degree. So second degree would be a quadratic, third degree is a cubic. So these are curves rather than lines, but the process is the same to find the inverse. So we'll do example 2, letter A. So I'm going to rewrite this as x equals y minus 6 squared plus 2. So now we just need to know a little bit more in order to solve this for y, but the idea is the same. We're undoing to get y by itself. So we're going to subtract 2. Well, to undo a square, we're going to square root. Whatever we do to one side, we got to do the other side. So that gives us y minus 6. Now we add 6. So when we solve that, we get square root of the quantity x minus 2 plus 6. That plus 6 is not under the root. Notice this didn't start in function notation, so I don't need to write my answer. So this is the inverse. Now notice when we start with a quadratic, our inverse is a radical function or a root function, a square root to be more specific. Since I ended with a square, the inverse is a square root function. All right, you guys try letter B. Check your answer for example 2, letter B. Remember, when we're solving, we always work in reverse order of operations, and that's why we undo the subtraction first, then undo the multiplication, and then undo the exponent. So our inverse is this function up here, y equals the square root of x plus 8 over 3 minus 5. All right, I'm going to do C. D is going to be homework. So now I'm starting with a cubic function. Same idea, I'm going to switch x and y. Now I'm going to have to solve for y. So I'm going to undo the 1 first. Okay, now everything I need is under that power of 3. So to undo that power of 3, I'm going to take a cube root. Now I'm going to solve for y. So I'm going to subtract 4. Notice I can't move that under the root. Now I need to divide everything by 3. So the inverse will be y equals the cube root of x minus 1 minus 4 divided by 3. So your homework is to complete example 2, letter D. All right, our last set of examples deal with log and exponential functions. Remember, when we talked about log and exponential functions, we already said they're inverse functions of each other. So the first thing we need to do is what we did before, is change this in terms of the x and the y. So it'll be log now we need to solve this for y. So remember, we have that definition that log base b of x equals y, and then b to the y equals x. So we can write this exponentially. Now to solve this for y, we just got to divide by -2. So y equals 5 to the x divided by -2. Okay, I'm going to go down and do this exponential one. So we'll start by writing, switching x and y. Now we need to solve this for y. So we'll add 5. So x plus 5 equals 6 to the y. And then from here we can write this using logs. So I'll take either the natural log or the common log of each side. So I have log of x plus 5 equals log of 6 to the y. Remember, by one of the properties, now this will come down in front. Now to solve this for y, I'm going to divide by log of 6, so y will equal log of x plus 5 divided by log of 6. Okay, so now I want you guys to try, so pause the video and try f and h, and then check your answers. Okay, so if you look at letter F,
Grace Gallagher and Claire Gallagher.
Here's the work and the answer for letter F. You end up with 3 to the x plus 6 minus 1 over 4. And for H, you end up with y equals log of x minus 2 divided by log 11.